school's out, blame corona, but I still got some science I could show ya. No class, no school, that's cool, throw the class on the YouTube. Even if they shut the school down, I'll get that knowledge anyway somehow. Real scholars won't stop for corona. Tune in for that science takeover.
Welcome to Mrs. Finney's science class. Shout out to the HB Warriors, to all of our subscribers, and to all of our visitors. From my home to your home, let's learn science. We are now in our 8th week of online learning. I'm so excited. This is amazing. We are still learning together. So let's get into our lesson for today. We're now in lesson 9, but today we're in section 3. Section 3 is titled Sex Cells Contribute Chromosomes. Learn objective. I can explain how sex cells contribute chromosomes. Really straightforward. All right, so we want to get into this lesson. At the top it says, here is a puzzle for you. If every human has 46 chromosomes in their cells, we already know that, and an offspring gets its chromosomes from both its parents, why does the offspring not have 92 chromosomes? Are you puzzled by this? Let's talk about it. Remember that the 46 chromosomes found in a cell are 23 pairs of chromosomes. Sex cells, eggs and sperm, have only 23 chromosomes or one copy of each pair. This is because when these cells are formed, the body cell that divides into an egg or sperm does not make a copy of its chromosomes before its final division into a sex cell. Instead, the body cell contributes only one copy of each chromosome to the newly formed sex cell as shown in figure 3A. Let's take a look at figure 3A a little bit more up close. All right, so we have sex cells have one copy of each chromosome. So here we have mother's body cell. We have father's body cell. Okay, we have mother's egg, father's sperm, okay? Take a look, see what's happening. Sex cells, eggs and sperm have only one copy, okay? See, you probably can't see that from there, but I'll shrink it down after reading this, of every chromosome instead of 2 like the body cells. They randomly get one copy of every chromosome, so different egg cells and different sperm cells carry different combinations of alleles from one another. Take a look at this. See what I mean? Okay, you see right here how you have 2, but then in the mother's egg, one copy. Same with the father. 2. And then in the sperm, one copy. Okay? So here it then says which of the chromosomes in the pair goes into the sex cell is completely random, or an event that happens in which the outcome cannot be predicted before it occurs. So some eggs might have the first copy of chromosome 1, but the second copy of chromosome 2, while another egg has the opposite. Okay? How then does almost every cell of the human body get 46 chromosomes? When egg and sperm unite to form the single cell that develops into an offspring, each contribute its one copy of each chromosome to the resulting merged cell. This gives the new offspring 46 chromosomes, 23 from the mother's egg and 23 from the father's sperm. As a result, there are 2 copies, or 1 pair, of every kind of chromosome in a person's cell. Like the offspring of a corgi and husky dogs has traits from both of its parents, human offspring have the traits from both of their biological parents. Figure 3b is a model of how chromosomes are passed from parents to offspring in humans. Like the corgi husky puppy, the offspring inherited 1 copy of every chromosome from his mother's egg and the other copy from his father's sperm. So take a look. Here we go. In the human case, okay, mother's egg has 1 copy of every chromosome. Look at mom. Oh, happy. Oh, it's so beautiful. 1 copy of every chromosome. 1 copy of every chromosome. Okay, let me stop. I will. Here we go. So you get 1 copy of every chromosome from the mom, 1 copy of every chromosome from the father. All right? The chromosomes from the mother's egg and the father's sperm combine into 1 cell. The offspring develops from that one cell. 1 copy of every chromosome. Okay, here we go. If you end up singing that later in today, at least, it'll help you remember like how this works or whatever. Didn't mean to make that stick in your head. So anyway, that's how that happens. Okay? Human offspring inherit 1 set of chromosomes from their biological mother and another set from their biological father. Offspring share some traits of each parent because the genes that control the expression of these traits are passed from both parents to the offspring on their chromosomes. 1 copy of every chromosome. Woo, woo. 1 copy of every chromosome. Woo, woo. Woo, woo. Okay. Oh my God. Next. Together, the merged egg and sperm cell divided and developed into the boy. As a result, he has 2 copies of every chromosome, 1 from his mother and the other from his father, and all of his body cells. On those chromosomes are versions, or alleles, fancy word, of genes. This boy will have traits that were coded for in the alleles that he got from his mother and the alleles that he got from his father. So he will have a unique combination of traits that will be different from either parent. See? We're so unique. There's something special about you. Something special about me. Because we all have our own combination of chromosomes. Because we all have our own combination of chromosomes. Sing it, 'cause we all have our own combination of. Because we all have our own combination of chromosomes. Ooh. Okay, here we go. Check for understanding. I really enjoy having class with you all. Drag the terms to their appropriate locations. Here we go. Word bank, word bank. 44, neither. 22, both. 46, 1, 23, only. 1, 50, 25. Ooh, this is a lot. We can do it. Human sex cells have blank chromosomes, or 1 of each pair. Ooh, what do you think? What do you think? I literally want you to be able to connect with me right now verbally. That would be great. Human sex cells have blank chromosomes, or 1 of each pair. When egg and sperm unite to form the single cell that develops into an offspring, each contributes blank copy of each chromosome, giving the new offspring blank chromosomes. Human offspring have traits from blank of their biological parents. Let's see. Human sex cells have It would need to be what? I don't know. You really want to go 46? You want to go 23? We'll have to see. When egg and sperm unite to form the single cell that develops into an offspring, each contributes blank copy of each chromosome. Only one? Okay, let's see. Giving the new offspring, what would you say? Giving the new offspring, you want to say 46 chromosomes? All right. Human offspring have traits from both of their biological parents? I don't know. You feel confident about this? I need to change something. Let's see. Yeah, something's off here. What will we switch? Each contributes blank copy of each chromosome. What should we switch that to? Just switch it to 1. Okay. Let's take that out. Okay. Let's see. Would that work? 1. All right, here we go. Human sex cells have 23 chromosomes, or 1 of each pair. When egg and sperm unite to form the single cell that develops into an offspring, each contributes 1 copy of each chromosome, giving the new offspring 46 chromosomes. Human offspring have traits from both of their biological parents. Good job, nice work. All right, here we go. In your TCI Lesson 9, Section 3, answer these questions here with me. Start with number 1. How are sex cells different from other cells? See, they only have 23 chromosomes in each instead of 46. All right, make sure you write that down. Number 1. Number 2, how are sex cells made? What's the process? How do we do this? I feel like a superhero or something asking this question. Here we go. The body cell that divides to make it does not copy its chromosomes first. A little different, a little different. Write this down. That is number 2. Number 3, why aren't all the sex cells from one individual identical? Good question. I think this is a really good question. Why aren't they identical? Each sex cell just gets 1 of the 2 chromosomes from the original cell. Remember that image we looked at. Okay? Make sure you write this down. And number 4, how does a new growing offspring have 46 chromosomes per cell? How? How is this happening? 2 sex cells combine, each bringing 23 chromosomes. I have my 23 chromosomes. You have your 23 chromosomes. Ooh, yeah, yeah. Moving on. Here we go. Why does an offspring resulting from sexual reproduction have traits from both parents? Deep question. If you can answer this one, kudos, kudos. Think about it. The offspring gets genes from both parents, and some from each will dominate the development of different traits. Shrink this down so you can see the entire statement all at once. And this is number 5. All right, next one. Use 2 colored pens to draw in the chromosome sets and show how 2 eggs from one mother can have different chromosomes and 2 sperm from one father can have different chromosomes. Let's take a look here. And we saw an image like this before, right? All right, here is an illustration. Okay, see how each have 2 different colors? All right, and in some cases you have purple here, some cases you have the red. Okay, one goes here, one goes there, and it's just a random chance of which one goes where. All right, make sure you draw this image, something similar. Put your own spin on it. All right, so we want to wrap up and make sure we can answer this essential question. Every human has 46 chromosomes in their cells, and an offspring gets its chromosomes from both its parents. Why does the offspring not have 92 chromosomes? Answer: when egg and sperm unite to form the single cell that divides into an offspring, each contributes its 1 copy of each chromosome to the resulting merged cell. This gives the new offspring 46 chromosomes, 23 from the mother's egg and 23 from the father's sperm. There we go. That's why we do not end up with 92. All right, I think we are good to go for today. Let's wrap up with the outro. First day of week 8. Here we go, here we go, here we go. Here we go, here we go, here we go. All right, here we go. Sing it from your heart. I know you know this. It's been fun. It's been real. We break it down and pick up science skills. Give yourself 2 claps just for tuning in. Come back, meet tomorrow. We can learn again. Oh, it's been fun. It's been real. We break it down and pick up science skills. Give yourself 2 claps just for tuning in. Come back, meet tomorrow. We can learn again. Have a great rest of your day. I will see you tomorrow. Peace.